Hello everyone and welcome back. I am Mr. Cobalt, and in this video I'm going to go over combustion reactions. And one of the things you need to know about combustion reactions are that combustion reactions are any reactions that where you are reacting with oxygen to form a product that has oxygen in it. And a lot of these problems, and I would say probably all of them, in a lot of the combustion reactions, heat is also produced as well. And so what I have here are some few examples where you have some carbon and hydrogen based molecules that are reacting with oxygen. So what will happen is if you have something with carbon in it, when that reacts with oxygen, you'll get your carbon dioxide. If you have hydrogen in it, that will react with oxygen to form your water. So by and large, usually the products in your combustion reactions are going to be carbon dioxide and water if you have a hydrocarbon or something that has hydrogen and carbon in it. Usually water is going to be a product of this reaction. So here we have ethanol. And ethanol has carbon, hydrogen, and oxygen in it. And we know that this is an alcohol because it has an OH group. So we call it methanol or ethanol. Right, eth means you have two carbons. And so that's eth, and the OL ending tells you have an alcohol. So ethanol reacting with oxygen. Again, we have carbon and hydrogen. And those are going to react to form, the carbon is going to form the carbon dioxide, and the hydrogen is going to form the water. Okay. Here again we have carbon and oxygen, and so you have pure carbon element reacting with oxygen. That's going to form just carbon dioxide. There's no hydrogen, so no water is formed. And here we have hydrogen, right? No carbon, so just hydrogen reacting with oxygen, and you only get water. And so if you pay attention to the pattern here regarding the combustion reactions and what they form, you can then predict what products are going to be formed from a given combustion reaction of a substance that they give you, right? So here we have two substances, and here we have a substance that just has carbon, hydrogen, oxygen, and if we're assuming complete combustion here. So if it's incomplete combustion, then you'll get other products or byproducts that form. But under complete combustion, you're only going to get carbon dioxide and water if you have a hydrocarbon or something that only has carbon, hydrogen, or carbon, hydrogen, oxygen in it. So here we have something with carbon, hydrogen, oxygen. If they ask you, okay, what is the combustion reaction for this substance, and that's all they give you, then you should know, oh, well, I know other combustion reactions, and I know that if something reacts with oxygen, if you have a hydrocarbon that has carbon, hydrogen, oxygen in it, and that reacts completely with oxygen and it's complete combustion, then you would know that you get carbon dioxide and water from this. That those are the only two products. So you know the other reactant is oxygen because it's combustion, and you know because this is a hydrocarbon that it's going to produce carbon dioxide and water. So you've got the equation right there. So you want to write out the equation. So it's going to react with oxygen because it's a combustion reaction, O2. And you know that because it's got carbon, hydrogen, oxygen, it's going to produce carbon dioxide gas plus water gas or water vapor. So now you have your equation with the products and reactants. Now all you need to do is balance. So again, you leave the pure element to later, and you balance the elements in the compounds first. So carbon, we'll start with carbon. Carbon 1, 1, so that's already balanced. Hydrogen, I have 4 hydrogens here, and I have 2 hydrogens there. So I'm going to put a 2 here. 2 times 2 is 4, so now I have 4 and 4, so that's balanced. My carbons are still balanced. So now the last one is oxygen. So I'm going to balance the oxygen by playing around with the coefficient for the free element. So here I have three oxygens. Here I have 2 here, 2 oxygens here, and 2 times 1 is 2, so I have 2 here. So I have 4 total. Oops. So I have 4 total oxygens on this side. I have 3 on this side. So what can I multiply this by to get 4? Okay, so I have 1 here, so I need 3. So what times 2 is going to give me 3 so that I have a total of 4? And that's going to be 1.5. So 3 halves, right? So 3 halves. So 2 times 3 halves gives me 3. So I'll have 3 here plus 1 gives me 4. So now I have a balanced equation. So I have a fraction there which allows me to balance the equation, which is fine. But now I have to get rid of the fraction without unbalancing the equation. So I need to multiply by 2 to get rid of the fraction. So I multiply everything by 2. So I'm going to multiply all the coefficients by 2. So 1 times 2 is 2. 3 halves times 2 is 3. 1 times 2 is 2. And then 2 times 2 is 4. So that would be the balanced equation for this combustion reaction, right? So again, I base this on my understanding of the common pattern of other combustion reactions. So now I have this substance here. I have carbon, hydrogen, and now I have sulfur. So if I have sulfur in there and it's going to react with oxygen, what do you think is going to be produced? Instead of like carbon, if I was reacting with oxygen and sulfur, what might be produced based on the pattern? If you said SO2, you would be correct. So that's going to be one of the products. So we have carbon, so we're going to get carbon dioxide, we have hydrogen, so we have water, and then we have sulfur, which is going to produce sulfur dioxide as well. So we're going to have oxygen as a reactant, and that's going to produce, again, carbon dioxide gas plus sulfur dioxide gas, and then plus water gas. So we're going to get those 3 substances. So now we need to balance the equation. And so here, since we have oxygen as an element, we're going to save that for later. So we're going to look at the carbon. So I have 2 here. So I'm going to put a 2 coefficient here. 2 times 1 is 2. Remember, I'm not changing the formulas. I'm only working with the coefficients. So I have 2 and 2. So now for hydrogen, I have 6 hydrogen, and I have 2 hydrogen there. So if I put 3, so 3 times 2 is 6. So now my hydrogens are balanced. And what about sulfur? So sulfur, I have 1 sulfur and I have 1 sulfur. So that's already balanced. So everything is balanced except for the oxygen. So now I can play around with this one. So since I have the oxygen element by itself, you're going to manipulate this one. You're going to figure out what coefficient you need here rather than here, because it's a lot easier to deal with this. Because you're not going to change anything else by changing this. You're only going to change the oxygen. So I have 2 oxygens on this side. I have 2 times 2 is 4. I have 4 oxygens here. I have 2 oxygens there. and I have 3 times 1 is 3, so I have 4 plus 2 plus 3 gives me 9. So I have 9 oxygens. So I need 9 oxygens here. So 2 times what gives me 9? And that's going to be 4.5, or otherwise known as, let's see, 9 halves. So now I have everything balanced. And so now all I need to do is get rid of the half. So I multiply everything by 2. So 2 times 1 is 2, so I put a 2 there. 9 halves times 2 is 9. 2 times 2 is 4. And then 2 times 1 is 2. And then 3 times 2 is 6. So that would be the balanced equation for this combustion reaction. I hope that was helpful, and I hope it's clear what combustion reactions are, and that you can, if your professor or the textbook or whatever homework you have, if they give you a particular compound and they say write the balanced equation for the combustion reaction, I hope this will help you out. If you have any questions, put them in the comment section. Make comments. Let me know what you think. If you like the video, like it, share it. Subscribe to the channel and ring the notification bell if you want to get more videos when I put them out. Thanks for joining me, and I'll see you next time.